Hello, 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 and welcome to Shiksha DaCosta. Today we're going to be starting a unit on connecting graphs and equations of exponential relations. In this unit, you're going to demonstrate that you understand exponents really well, and you can connect the numbers, the numerical expression of exponents, to the graph, and even to the algebraic expressions of them as well. And how do you know that you're good at doing all of these things? How do you know that you understand exponents? When you can determine using investigation the meaning of negative exponents and of zero as an exponent, when you can evaluate using technology and even without technology, what is a numeric expression that contains integer exponents? That means the exponents could be positive or they could be negative, right? Negative exponents is something we're going to be looking at. And rational bases. So the base of the power is a rational number, in other words, a fraction. Also, when you can determine through investigation, what are the rules for multiplying and dividing expressions that involve exponents, as well as the rule for simplifying one's exponents that have a power of a power. Just continuing on, then once we're done with the algebra of exponents, we're going to look into graphs. So at this point, you should be able to graph really simple exponential relations using a paper and pencil, not using a graphing calculator, if I give you their equations. And when you can make and describe connections between the different ways that an exponent could be represented. And finally, when you can distinguish, which means tell the difference between exponential relations and linear and quadratic relations by making all sorts of different comparisons. So just to start us off here, let's look at just a very basic idea that you will have learned in mathematics many years ago. When playing Monopoly, Declan gets a card that says collect $50 from each player. There are 4 other players, so to find out how much he is actually owed, how much money he needs to collect, he does 50 plus 50 plus 50 plus 50. What operation would have been faster than adding 50 4 times? Well, the answer is pretty easily 50 times 4. We would use the multiplication operation. And in maybe grade 3 or grade 4, you learned about multiplication. You learned that repeatedly adding the same number again and again and again 4 times is kind of boring. It's kind of slow. So we mathematicians, every good mathematician is pretty lazy because they want to find the easiest way to get something done. And the easier way than adding 54 times is just to do 50 times 4, to do this operation called multiplication. Now Declan says, I want to make my own game. Okay, he likes, army stuff, and in his game, players will battle to control areas with armies of soldiers. And these soldiers are represented by tiny little figurines. And he wants players to make groups of soldiers so that they're attacking with groups instead of just, one soldier at a time. And so he decides that his game is going to have the following rules. 3 soldiers together are going to form a fire team. So you could say, I'm going to send 1 fire team here, 1 fire team there. Three fire teams together will form a squad. How many soldiers are in a squad? This right here would be a fire team. That's 3 of them. And if I have 3 fire teams, that's 1 fire team, 2 fire teams, 3 fire teams. Then to find out how many soldiers would be in a squad, I would do 3 times 3. I have 3 groups of 3. Here is my first group, right over here. Here's my second group, and here is my third group. 3 groups of 3 means I do 3 times 3, that's 9. And then Declan says, 3 squads will form a platoon. So if you want to send a platoon somewhere, how many soldiers are you sending then? We know that in this squad, there were 9 soldiers. And so because we have 3 squads in a platoon, 9 times 3 would give us 27 soldiers. And Declan continues along this lines. He says, okay, how many 3 platoons? 3 platoons will form a company. And 3 companies form a battalion. And this is the largest group that Declan cares to include in his game. So I guess the question becomes, how many soldiers will be in a battalion? Look how many there are just from this diagram here. And when planning his game, Declan needs to understand this so that he knows how many little figurines to include in his game. How many does he have to give to each player? Similar to how Declan, when he was playing Monopoly, he didn't want to, he did 50 plus 50 plus 50 plus 50, and we said that's useless. Let's make our lives easier and do 50 times 4. Very similarly here, we will, instead of doing 3 soldiers in a fire team times 3 fire teams in a squad times 3 squads in a platoon times 3 platoons in a company times 3 companies in a battalion, instead of multiplying the same number by itself 5 times, we're going to use another operation now, and this is one that you should have learned already by this point. This is the exponential operation. This is something called a power. 3 to the power of 5 means we are taking this number 3 and multiplying it by itself a total of 5 times. And the total for that would be 243. So what is this unit all going to be about? What did we learn, in fact, even in just this lesson? We learned that repeatedly adding something, the same number, could be made a little bit shorter by using multiplication. Repeated multiplication is this operation called exponentiation. A power is an expression of this operation. So this is how we write powers. There's a big number, and then up in the top right corner, there's a smaller number. The big number this is a power. The big number is called the base, and the smaller number up here is called the exponent. A power refers to the whole thing, the base to the power of the exponent. So the base is the number that's being multiplied by itself again and again and again. The exponent of a power is the number of times that we do multiply the base by itself. So just a quick example here. What is the expanded form of 9 to the power of 6? This is quite easily 9 times itself 6 times. Okay? And 9 to the power of 6, if I wanted to evaluate this, I could either put 9 times 9 times 9 times 9 times 9 times 9 in my calculator, or I could put 9 to the power of 6. Either way, I would get the number 531,441. This question is not asking me to evaluate it, just to write it in expanded form. So at this point, I am done. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.